8.2.1, 9, 9.4, 9.8. Do I hear 10? Do I hear 10.5? 10.4. And there she goes. She's dead. I wanted to share the results of building a circuit that I got from a guy named Co Tillman, a Dutchman. He's got a channel called Radio Fun 232, and I've been binge watching basically every video he's made because he makes really incredible circuits out of what looks like just garbage parts to some degree. One of the circuits that he posted a video about is called the Easy Sine Wave Generator. I've been trying to find a way to generate sine waves because I'm trying to build a local oscillator for some radio experiments. And in Co's video, he has a schematic that basically looks like this. He doesn't have a inductor on this side. He's specifying a 470 capacitor. I was having a hard time getting this circuit to oscillate. As soon as I substituted this capacitor out with an inductor, I was able to get really, in my opinion, pretty stunning results. I've got a very stable oscillator circuit now, and it's tunable. I can tune it from the kilohertz range all the way up into the megahertz range. Co also specified various values for resistors and capacitors, and I didn't exactly have all of these available, so I substituted some different values and got close. I do have a BC547B transistor, an NPN transistor, so I'm using that much at least. The other thing I'm using is 18 volts to power this, and I believe Co was using 12 volts. I also don't have a proper frequency counter, but I have this old Radio Shack multimeter with the duty cycle, and what I'm getting right here is 482 kilohertz, and that's the trace. Let's look at the circuit as it is now, and I'll show you kind of some of the cool things that you can do with this particular circuit. Alright, so here's the circuit. It's running. I've got a reading of 498.2, 500.2. It seems to be oscillating between those two values. Can't really see that here. We're kind of in the scope. It says it goes to 200 megahertz. Could that possibly be true? Is that really 2.00 megahertz? No, and the manual says as much, but it's an old scope, and I really can't get the trace to be any clearer than that. It's rather fuzzy. So that's what we got. You know, I know you should never do oscillator circuits on a breadboard. I've heard this before because of all the stray capacitance and all the wires, and this ought to be dead bugged. And I was looking at how Co was doing his circuits, and you know, he's even said it is that you can have long wires. It's not the end of the world. You can build fairly sturdy and reliable circuits in a lot of different ways. But this being a prototype, I really don't have any objection to giving it a shot on a breadboard. Big deal. So we can do some experiments here with this coil. If I stick a pencil inside of it, that brings the frequency up to about 516. It was at around 500. Here I've got an old ferrite rod with even the original coils, just the wires have been clipped off, and this thing was rescued out of an old radio. If we pop that in, we really see a massive difference in the frequency. If I carefully nudge this in, we're already at 683, now we're at 700, 800. The scope is starting to go into the megahertz range, 1.3 megahertz, 2.6, 3.3, 2.9, it's dropping to 1.5 and back up as I push this thing in farther and farther. If I put it all the way in, it looks like it wants to sit at around, I don't know, it's kind of bouncing around a little bit between 1.5 and 2. So it's not quite there yet, but this is a remarkable experiment because the results are just very tangible. They're happening right here, and I can see the possibilities. If I were to dead bug this whole thing as is, so that it's not adjustable, I have a reasonable expectation it would stick to a given frequency pretty reliably. The next thing I want to demonstrate is I want to pull this coil off. This was something I substituted for a given value on Co's diagram. I'm going to pull this out and pop in a capacitor, film capacitor. This film capacitor, I've got a bunch of different ones. Let's try like this guy. This, I believe, is like a Czechoslovakian military grade radio equipment capacitor. I'm going to put that in there, and we're at 2.174 kilohertz. Pretty nice looking trace. I can't tell if there's a little bit of clipping happening. I'm not sure. It's rather blurry and just the old scope, you know. One of the things that I did was I added 2 leads to an audio jack, and I'm running that into my stereo. So I'm going to play the annoyingly high-pitched squeal right now, so you can get a feel for the fact that this is actually working and functioning. So that's a 2.17 kilohertz tone. Now, I've got a trim pot that's shunting. Actually, it's not shunting at all. It's basically resisting between the same two leads as the capacitor. And from what I can tell, this trim pot seems to be attenuating the amplitude. I mean, clearly, that's what it's doing. It might be doing something with the frequency at not there, maybe right there where it's kind of shifts around a little bit. So if I stack on another capacitor at this same location, it's unbearable. There's clearly some clipping happening with this signal, and I think this capacitor tends to not be very, well, I don't know, it doesn't lend itself to a very harmonious sine wave. I really don't know. So up to this point I was getting, just with capacitors you're able to generate sine waves in the kilohertz spectrum. Cool. But hooking up a coil right here really makes this thing fly. I'm at 570 kilohertz as this coil is right now. If we were to maybe sand off some of the insulation, we could create some taps. See if we can't increase and decrease easily the frequency. I'm going to do that next and show you what the result. Just trying to give myself a little bit of a head start with that X-Acto blade and very carefully not cut through the wire completely, because then I'll be hooped. Time for the big guns. Alright, well, we got taps on our coils, and the default of this coil in all of its glory is something around 500 kilohertz. Disconnect one of the leads and we'll add in our tap. We'll see how close we can get to 500 just by tapping the end of the coil. Now I'm seeing 767 round about there. As I go inwards, let's try about there. 425 kilohertz. Let's go halfway. 151 kilohertz. We'll go all the way to about a centimeter in. 99 hertz. We'll just start going out from there. 461 hertz. 907 hertz. See, I'm not sure whether there's kind of some springiness in this entire circuit. There's a lot of opportunity for stray capacitance and inductance and just tank circuits sort of forming based on the geometry of all the wires. There we go. 95 hertz. How about just a couple of windings once or twice around the horn here? 72 hertz, of course. And if I just let it free, we should probably pick up the 60 cycle hertz in the room or some harmonic thereof, or it'll just go to 0. I've been seeing 60 quite a bit because being in the US and A, that's what it is here. So what we're doing right now is we're tapping this coil, and this capacitor has been removed. We're substituting that capacitor with this inductor, and also not shown here is a potentiometer between here and here. Well, I just threw that in. Not really sure if that's something that I need or want, but this is experimental, of course. In Ko's video, he says that this is a classical design, and I don't know what he means by that, but it's a good hint that this is not digital, other than this switch, but it's all analog happening here. There's no 555 timer. There's no Schmitt trigger. The waveform is being shaped by this down here. This coil is a major player in the whole circuit attaining some kind of oscillation. I think what I ought to do is put a potentiometer right here on this 12K and see what that does next. So I'm getting about 750, 760 kilohertz with this. I'm going to stick the ferrite rod into tube where my inductor is. So now that this coil can be tapped, I should be able to control what band a little better. 880 kilohertz, 2.5 megahertz, 3 megahertz, 900 kilohertz, 1.28 megahertz. What happens if I go all the way down to this end? 902 hertz. Interesting. Very interesting. 3.9 megahertz. This is pretty cool. I'm so happy with this circuit. I can't thank Ko Tillman enough. Ko's channel is called Radio Fun 232. You gotta look it up. I've been binge watching this guy for about 2 weeks now, trying to just soak it all in. He's a genius, and Ko knows what he's talking about. He'll do the math for you. Whereas I'm more of just a kind of experimental home gamer, just trying out different things. And I have searched high and low for a reliable home-built oscillating circuit, and I think I found it. This could keep me busy for a long, long time. So we'll be doing a lot more videos using this kind of a circuit, and I'm certainly going to dead bug many versions of this. And we're going to try to build some radio using local oscillators. Not surprisingly, the audio cable that I had attached to my stereo to this this board was creating a huge amount of attenuation of this frequency. I've got this thing at 5.4 megahertz after I disconnected that audio connection. So the only part of the outside world this thing is connected to is the scope. And I'm sure once I take the scope off, the duty cycle might increase then as well. Yeah, 7.5 megahertz. So that says a lot about keeping the circuit concise and having the length of wires short and no interference from the outside. Obviously, being a radio or being part of a radio, you want to reduce your interference. All that stuff's obvious to people that know what they're doing, but not me, and I'm having to kind of learn all this stuff from the ground up. At this point, this circuit is not incredibly stable. It's bouncing around from 5 megahertz back down to about 1. That's pretty interesting. I think if I put in the ferrite into the coil, does that help stabilize it? No, it absolutely kills the oscillation. The 60 hertz, it's just picking up the room. If I put the ferrite in about a quarter of the way into this tube, I'm hesitant to say that is stabilizing the frequency, but it has leveled off at 4.5 megahertz. So anyways, there's a lot to be done here, and I just love this circuit. I think it's great. A lot of fun. Now that it seems like it's stable, we can try to tap into this coil a little bit, see if we can't get some other reading. So here we have the full length of this coil, and we're not getting any oscillation. There we go. I pulled the ferrite out, and we're at 3.6 megahertz, 693 kilohertz. 1.7, 3, 4 megahertz, 3.9, and it's a very ripply looking trace, and all I can think of is that that's a frequency trace with a 60 hertz overlay of some kind. Just because typically this scope just picks up whatever's going on in the room, which is always 60 hertz. Especially if you got like a wire dingle-dangling around picking up all the RF. Even when I change the settings on the time division knob, it's messing with the duty cycle readout. At this point, I expect that kind of interference. So in Ko's example, he's got a 12K fixed resistor right here. I just put in a 10K pot, substituting that, and I'm getting 6.5 megahertz now. I'm able to really crank up or crank down frequency and also just screw it up completely. There's definitely a zone where this circuit wants to be stable, and that's what I got to figure out next. I think just heuristically is going to be how I go about it. That's not too bad though. It's not shifting around too much. I think that might be able to be, I can't tell whether I'm smoking this thing out. Is it anything getting hot? I'm running 18 volts through this, or almost. Probably like, might be around 16 or 17 volts, but there seems to be a sweet spot with this potentiometer with relation to getting that frequency to sit still, and I can't get it to go much higher than 6. However, I'm going to turn off the scope, disconnect the leads to the scope, and now we're at 7.5 megahertz, 7.6, and I killed it. But she popped right back to life there, 7.6 megahertz. Pretty interesting. Go check out Ko's channel, Radio Fun 232. I'll put a link down there and tag his channel because he's a genius. I love his work. And if you're looking for somebody who just gets stuff done with what they've got, he's your guy. So thanks, Ko. So there you have it. That's the Easy Sine Wave Generator version 1. Check this out. I put the ferrite rod into the coil. I'm getting 10 megahertz. Farther I stick this thing in there, now it tends to kill it. 9, 10, 10.4, 10.5. Come on, baby. Come on. Oh! Let's try it again. 8.2.1, 9, 9.4, 9.8. Do I hear 10? Do I hear 10.5? No, 10.4. And there she goes. She's dead. Well, thanks for watching. Keep smoking up your op amps.